Welcome to our first step in building a machine learning model. In this example, we are focusing on data generation. Before we can train an AI, we need data to feed into it. Since we aren't loading an external file today, we are using a powerful tool from the scikit-learn library called make classification. This function allows us to create a synthetic or fake dataset that mimics real-world patterns, which is incredibly useful for practicing our skills without needing a massive database. Let's look at the key parameters here. We've set n samples to 60, meaning we are creating data for 60 different individuals. We've defined 4 features, which are the characteristics the AI will look at, and specified that 3 of those are informative. In AI terms, an informative feature is one that actually helps predict the outcome, while a redundant feature would be a duplicate that adds no new value. We also use a random state of 42. Think of this as a seed that ensures every time you run this code, you get the exact same random numbers, making your results reproducible for your classmates. Once we have these raw numbers, we wrap them in a pandas DataFrame. Pandas is essentially like an Excel spreadsheet for Python, allowing us to organize data into rows and columns. We've given our features descriptive names like age score and income score to make the data human readable. Finally, we add a target column, which serves as the answer key, telling the AI whether the outcome for that row is a 0 or a 1. Now let's examine the output from the head function. You'll notice a table showing the first 5 rows of our dataset. The values in the score columns are decimal numbers, which is common in ML because it means the data is scaled or normalized. Look closely at the target column. You can see values like 1 and 0. This confirms we have a binary classification problem, where the goal is to categorize each row into one of 2 groups. This structured table is the perfect foundation for our model to start learning patterns. Now that we have our dataset ready, we move on to one of the most critical steps in machine learning, splitting our data. In this example, we use the train test split function. You might wonder why we don't just use all our data for training. The reason is a concept called overfitting. If an AI sees all the answers during its study session, it might simply memorize the data instead of learning the actual patterns. To prevent this, we split the data into a training set, which is like a practice textbook, and a testing set, which acts as the final exam. Notice the line where we use df.drop. We are separating our features, which we call x, from our target labels, which we call y. This ensures the model doesn't accidentally cheat by seeing the answer while it's trying to learn. We've set the test size to 0.25, meaning 25% of our data is reserved for testing, while 75% is used for training. Looking at the output, we see that we have 45 training rows and 15 testing rows. This matches our 75-25 split perfectly, since 25% of 60 is 15. This distribution is important because it gives the model enough examples to find a pattern in the 45 rows, while still leaving a statistically significant group of 15 rows to verify if the model actually works on data it has never seen before. The takeaway here is that by isolating our test data, we can get an honest measurement of how our AI will perform in the real world. Look at the output now on screen. Read the printed values, notice what they tell us about the step we just ran, and confirm they match what we expected from the code.